Hi, I'm Ray. Today we're going to talk about agents and the fact that Project Intu is an agent-based system. And I want to talk about an example of a set of agents that are in Self and how together they create an interesting experience, much more unique than just a simple question answer. And the example is a concierge device, robot embodiment for a hotel or in your house. And as you know from Grady's talk with Project Intu, is in Watson's embodied cognition, and underneath Project Intu is the architecture based on Self. So the example I'm going to talk about is a concierge use case, and the set of agents that are going to be interacting, working independently of each other, and I'll explain that in a minute, is, here's some examples. So a greeter agent, so an agent running in Self whose sole responsibility is to greet a person. Imagine an emotion agent, and the sole purpose of an emotion agent is to detect the emotion of the person that they're talking to. The person is happy, the person is sad, and this is of course using the Watson emotion detection tone analyzer service. We have a question agent, and its sole job is to answer questions that are asked using Watson Conversation, using Watson Engagement Advisor, etc. We have a naming agent, and this sole purpose of this agent's job is to be told what its name is and know what its name is to give an appropriate answer. We have a health agent whose sole responsibility is to monitor the health of the device, and if it has something wrong, a battery needs to be charged, it can take action on the health, independently of everything else. We have a thinking agent whose sole responsibility, again, independently is if you ask it a question and the answer takes some time to figure out, the agent can look like it's thinking and give the behavior of thinking, and this agent makes that determination and can show that kind of a display. Imagine a weather agent that is detecting the weather outside periodically and storing the fact that it has some weather pattern. Imagine a time agent that's keeping track of the time of the day. And imagine we have a gesture agent as well that's doing gesturing and pointing, but some form of gesture that can be had depending on what kind of question is being asked. And then a random interaction agent that makes things more interesting. So if the robot is sitting there in the lobby, every so often it'll say hi or make some movement that lets someone know that it's there. Now, all these agents working, why are they uniquely different than just asking a question? So imagine asking a question about a restaurant, or imagine asking a question that you want to go into a party. Now, all these agents have been providing and reasoning over the environment, and the weather agent knows that it's raining outside. The emotion agent knows that you're in a hurry because of the way you've asked the question. So in our conversational system, we would give you a response uniquely tailored to that experience. So if you're in a hurry, you want a short response. If you're going to go outside to a restaurant and it's raining, the conversation system would maybe suggest an umbrella because we know that it's raining. Now imagine that the robot is in fact its battery is charging. As part of the interaction, the robot could say, by the way, I need to charge my battery. Can you help me and plug me in? Imagine it's nighttime or it's early morning, and the agent that has the time agent knows that this is in fact the case. The conversation system can say, by the way, you will need extra time because the traffic is really bad this time of the morning. So by having these individual agents that are recognizing things in the world and keeping track of these things in the world, we can give a much better experience and a much more impression that the system is intelligent. Agents are behavior that acts independently of each other. So the weather agent is acting independent of the time agent, is acting independent of the emotion agent. These things are all just collecting information and composing all this information into what we call the blackboard. Agents act on this. So when you ask a question, there's a goal that gets generated that says answer the question. And the conversation system can answer the question. The emotion agent can interject emotion into the response. And even example, the gesture agent that we have can say, oh, you're saying I want you to go to the elevator to the right. We can point to the right. Robot answering the question. The agent can also say, hey, I want to present a new goal to the blackboard that you need to act on. And that goal can be start the car. So if I'm going to go outside and it's cold, then agent that is answering the question can say, oh, I just answered a question about a restaurant. You're going to go outside. Let's put a goal on the blackboard that says, hey, how about I start the car for you before you go outside? And that agent can act independently of the rest of the agents to go and start that vehicle. So the power of an agent-based system is that these individual agents are working independently. We can add more agents, and the more agents we add to the system, the more the system is perceived to be more and more intelligent. And this combination of the agents and its behavior gives the impression to the user that this embodiment is exceptionally intelligent because it's understanding all these things. This is an example of one of the powers of self and one of the powers of what we call an agent-based system.